is Syakirah from Group 5. We will present about siphon and cavitation. Now, I will introduce about siphon first. Siphon is a tube which is used to draw a liquid from a higher container to a lower container with presence of atmospheric pressure and gravity by suction or immersion. So, how does siphon work? According to the definition, we need to submerge the tube into a higher container first. Then, by suction, we need to suck the other end of tube till the water from the higher container inserts the tube till the halfway and put it into a lower container. The important thing here is the tube must contain 1/3 of the water or it will never suck the liquid from the higher container at all. So that is how siphon works. Related to Bernoulli's equation, the siphon works when the hydrostatic pressure causes the end of the tube with lower elevation to have a greater velocity. This causes a reduced pressure at top of siphon. Liquid flows upwards due to a lower pressure which pushed by atmospheric pressure.
Cavitation is defined as the formation of vapor-phase cavities or bubbles within a liquid, which usually due to rapid changes in localized pressure. Various mechanical parts such as pumps, control valves, and propellers can cause the cavitation to occur. There are two types of cavitation. The first one is the inertial cavitation. It refers to the formation of vapor cavities, which proceed to rapidly collapse and causing a shock wave. The second one is a non-inertial cavitation. It is the oscillation of the size and shape of the vapor cavities. When did the cavitation occurs? The cavitation may occur when a pressure drop occurs within a region of a fluid to a point below the vapor pressure of the fluid at the current temperature. At this point, the state change from liquid to gas occurs, creating a bubble. The pressure drop can be achieved in numerous ways, including the acceleration of the liquid as in a waterfall or propeller. After the cavities are created, the low pressure bubbles cannot sustain their form because they are surrounded by a higher pressure fluid, and they subsequently collapse. The collapse of the bubble causes the gas inside to pressurize and heat up, and a shock wave forms with high pressure and temperature. Noise and light may also form. As mechanical parts may cause cavitation, these shock waves can occur close to the part surface, causing damage and pitting. The pitted surface causes more fluid turbulence and in turn causes more cavitation. Thus, the cavitation continuously damages the surfaces and facilitates the corrosion of the metal. Here are some of the examples of the cavitation damage. So, how can we control the cavitation? Here are listed some of the solutions. First, we can redesign the systems. Second, we can change the materials. Lastly, we can also reduce the pressure from inlet to outlet gradually. Thus, it will avoid a large pressure drop.
So, this is the question part for siphon and cavitation. The question is, determine the maximum height of the hill H over which the water can be siphoned without cavitation occurring.
So, from the question, at point 1 is free surface. At point 2, the peak elevation is equal to lowest pressure. At point 3 is free jet. Next. So, we will apply Bernoulli equation at point 1 and point 2, Z1 equals to 15 feet. So, we simplify the equation, then we get Z2 equals to P ATM minus P vapor over rho G minus V22 over 2G plus Z1. Then we will apply the equation at point 1 and point 3. Z1 equals to 15 feet, Z3 equals to negative 5 feet. Using continuity equation, we get V2 equals to V3. So we again simplify the equation. V2 equals to V3 equals to Z2G Z1 minus Z2. So we get V vapor equals to 0.256, G equals to 32.2 feet per square. PATM we get 101.3 kPa. Then substitute the values into V2. So we get V2 equals to V3 and we get 35.88 feet per second.
After we insert all formula and data givens, we get the maximum height, that is 28.3 feet.